Hello everyone. So today we will be starting this video with numerical on FlowNet so that it becomes much more easier for you to understand the concept behind FlowNet. Okay, so today we will do a numerical on FlowNet. So there will be two situations in which you may have to do a numerical. First situation will be such that the diagram will be given to you. Okay, and you have to find out the q value. Okay, so what was the q value? Kh nf by nd, isn't it? So this we have already discussed. Q is equal to kh nf by nd in the previous video, like this one. So please go through it. So finally we have to end up getting the final discharge. Generally the flow net problem is about calculating the final discharge. Okay, so first one will be that diagram will be given and you have to find out q. Okay, using kh nf by nd, and k will be given to us. Okay, and h nf nd all will be all these things will be shown in the diagram. Okay, and the second one will be such that all these values k h nf and they will be provided to you. Then you have to draw a diagram using these values. Okay, k is not required in diagrams. Okay, and you have to draw the diagram using these values, and then you have to find q. Okay, so everything is interrelated. Okay, so let us do one problem. Let us do a problem where the diagram is provided to us. Okay, and then we have to find out total discharge, which is q. So let us start with the diagram. So this will be the midpoint. Okay, so let us assume that this is the problem given to us. Okay, the problem is given in the form of a diagram. Okay, so now the flow lines are given to us like this. Suppose one, then two, then 3. Okay, and this flow lines, this fourth one, this flow lines endpoint will be somewhere like far away. Okay, and this one is the impermeable layer. So this is the problem which is given to us in the form of a diagram, and equipotential lines are given to us. Okay, so I'll draw it to you. Like this. Okay, so suppose here there is the head. Let us take the head difference as 2 only. So let us take the same values as before, 2.25, and this is suppose 0.25. So difference, total head difference between the initial and final head is 2. So H is equal to 2. Okay, initial head is 2.25 from where the water starts flowing, and after it flows and it reaches the other side, its head becomes 0.25. So that is the final head. So what is the total head that it has changed? That is 2, isn't it? So that H is the head difference, okay, which will be used in the formula. Okay, KH NF by ND. In that formula we have to use H equal to 2 here. So first value we have got H equal to 2. Okay, and our ultimate problem is to find out Q. Okay, Q is equal to KH NF by ND. So Q is given to us. Okay, Q is given to us. It is 5 into 10 to the power minus 3 centimeter per second. Okay, so Q is a given value to us. It will be generally provided to you. It is a property of the soil. So K and H are done. So you can see already half of the value is already calculated. We just have to find out now this NF and ND. So how will you find NF? So just see what how many flow channels are there. Okay, so you can try to just imagine. Okay, just not imagine, visualize. uh, this one this one will be one flow channel. Okay, the water will come here. This one is one flow channel. Okay, what is the general definition of a flow channel? The general definition of a flow channel is the path, is the space between two flow lines, isn't it? The space between two flow lines is a flow channel, and I have already told you that the there is a flow line here, isn't it, in the sheet pile. If you just follow the previous diagram, there will be a flow line here, isn't it? And there is another, this is another flow line, isn't it? So this initial flow line which is in touch with the sheet pile, okay, this initial flow line and this flow line, let me consider this as one initial flow line. This one is the second flow line, this one is the third, this one is the fourth, okay, and this one is the fifth flow line. Okay, so first flow line is the path of liquid that travels from the left side to the right side through the sheet pile. Okay, through the sheet pile. I have already given you this idea in the last video. A particle of water just in contact with the sheet pile on the left will pass through the sheet pile, surface of the sheet pile, and move to the right side. Okay, and it will be totally in touch with the surface of the sheet pile. So that will be the first flow line. This will be the second flow line. Okay, and the other flow lines are already significant. Okay, already distinctly known to us. So first, and between first and second flow line there is one flow channel. Second and third flow line there is the second flow channel. Then third and fourth flow line there is the third flow channel. Okay, then fourth and fifth flow line there is the fourth flow channel. Okay, now here in the last, what is this? This surface, this impermeable surface, water will also like pass through the impermeable surface, right? In this manner from left to right. So somewhere some particle is there, some particle of water is there. Okay, like these particles of water are moving from left to right, isn't it? So somewhere very far away the water particle is coming like this, and then it is like moving through the surface of the impermeable layer. Okay, somewhere very far away the water particle is coming. Okay, and it is in contact with the permeable layer, impermeable layer. Okay, like this is the impermeable layer. Okay, it is in contact, and then it will move like this to the right side, and it will go very far. Okay, it is coming from very far, and it is coming from so far that like only half of the water will reach the endpoint. Okay, so now this one is a flow line. This water from the left from very far away, okay, water from the left from very far away is coming, and then it is in touch with the impermeable layer, and it is flowing. It is going to the right. Okay, so that is one flow line. So that can be considered as the sixth flow line. So there is the fifth flow channel, isn't it? There is the fifth flow channel, but in that fifth flow channel, uh, already we have got the first flow channel. Okay, this one is the first flow channel, this one is the second flow channel, this one is the third flow channel, isn't it? And this one is the fourth flow channel, and this one will be the fifth flow channel. Okay, now in this fifth flow channel the efficiency is 0.5. That means only half of the water of this flow channel is actually like will reach this side. Okay, it means in this flow channel only half of the water is ultimately like will reach this endpoint of 0.25. Okay, and the remaining half will just go, will never reach. This remaining half of this flow channel will never reach the endpoints. Okay, so the efficiency of the fifth flow channel is just zero point 0.5. Okay, so ultimately, practically speaking, there are 4.5 flow channels. Okay, so 4 flow channels are there already, and the fifth one is having just 50% efficiency. That means only 50% of the fifth flow channel is like will reach the endpoint. So NF will be, number of flow channels will be 4 plus zero point 0.5. Okay, so it will be 4.5. Then how what will be the number of equipotential drops? So let me just uh, erase this part and make it much more clear. Just bear with me. It may take a minute. So I've just redrawn it. Now, how many potential drops are there? Okay, so this is the starting point of the particle. Okay, so you can see any of the lines. Okay, the fourth flow line or the third flow line or the second or the first, you can see any of it. So how many potential drops are there? Every equipotential line, okay, so will be a potential drop. So this one is an equipotential line, this one is another equipotential line, this one is another, this one is another, isn't it? So every equipotential line there will be a drop. So there will be first drop, second drop, third drop, okay, fourth drop, fifth drop, sixth drop, seventh, eighth, ninth, 10, 11, 12. Okay, so number of potential drops will be 12. Okay, so how much is the like potential drop in how much will be the drop in how much will be the drop value actually? Okay, how much it is dropping in like in each part? Can you tell me? It will be 2 divided by 12. What will be 2 divided by 12? Just find it out. 2 divided by 12 will be somewhere around 0.16, okay, or 17. All right, so like point somewhere like 0.17, okay. Actually it is around 0.1666 something like that. So how much it is dropping at each stage? So 2.25 minus 0.17, so it will be here 2.08, like this it is dropping, and everywhere it is dropping by 0.17. Okay, so at the beginning it is 2.25, then at the first stage it has dropped by 0.17, it is 2.08. Similarly, at the next drop it is how much? 2.08 minus 0.17, so it will be 1.91, then 1.74. Okay, so like this it will move on, and ultimately at this endpoint it will become 0.25. So 12 drops, okay, and everywhere the drop is 0.17. So 12 drops everywhere, it is decreasing by 0.17. Okay, so ultimately we have got all the values. So we just have to now put it in the final equation. So just put it down. So Q equal to KH NF by ND. So 5 into 10 to the power minus 3. If I want to keep it in suppose meter, then I'll give 10 to the power minus 2. Okay, I'm converting the K in terms of meters. Okay, into H is in meter, NF number of flow channel 4.5 by number of potential drops is 12. Okay, so 4.5, I hope you have understood why it is 4.5, because four flow channels are completely like starting and ending, okay, from left to right, but the fifth flow channel only half of the water will be reaching the end point, okay, and the remaining half will never reach the beginning or the end. Okay, so the fifth flow channel is just 50% efficiency, so that's why the fifth flow channel we consider it as half, and ultimately we get 4.5. So I will not do the calculation, you do it yourself, but the main thing is clear. Okay, so I hope you have understood it. Okay, so now we will go to a new topic, which is about classification of soil. You see, we have already like discussed about soil classification based on their sizes, isn't it? But again, there are some more detailed classifications which are required, okay, for soil, for like judging their quality. Okay, So one such type of soil classification method is group index method. Okay, so we'll discuss a bit of soil classification methods from now. So uh, the first we will be discussing is GI method, or we can say group index method. And group index method is based on AASTHO classification. Okay, what is this AASTHO? It is American Association of State Highways and Transport Officials. And Transport Officials. This is the meaning of ASTO. Okay, and they have given the group index method, and let us see how we can calculate the soil quality. Group index method. And I'm sorry, I have done a little bit of silly mistake. It is AASHTO actually. Okay, not THO. It is HTO. Then that's why I was like thinking that something is wrong. So this is the full form of this is the main proper abbreviation. Okay, American Association of State Highways and Transport Officials. They have given this group index method. Okay, and let's see how what is all what's it what it is about. Okay, so the group index method, the formula is GI is equal to 0.2a plus 0.005 AC plus 0.01 BD. This is the formula for group index. Okay, and now uh, GI value, it ranges from 0 to 20, and sometimes if it comes negative, then we take it as 0. Okay, if negative, we take it as 0, and the lesser the better. Okay, if we get GI is 0, we can say that it is best. Okay, as the GI value increases, then the quality decreases. Quality decreases. Now let us see what is all this A, C, B, D. Okay, let us see. So I'll just write this formula once again. 0.2A so A is if we take a sample of soil, okay, if we take a sample of soil, the amount of the percentage of the sample which is passing through 75 micron. Okay, suppose we take a sample of soil, we sieve it. Okay, suppose 1 kilo of soil we are taking and we sieve it, and suppose we say that we see that 50% of the soil sample is passing through 75 micron sieve. So A will be we will be taking A is the what percentage, that will be taken as 50% will be taken into consideration as the percentage passing through 75 micron. Okay, so now just write down. Now what we have to do is, for this A, actually this part will be taken as X. Okay, and then with it we have to subtract minus 35. That means, I'll just make it more clear to you. If we take 1 kg of soil and we take a 50 micron sieve, sorry, 75 micron sieve, okay, and we are pouring the 75 micron 1 kg sample through it, and suppose 500 gram passes, so that means 50% is passing by the 75 micron sieve. So A will be, it's obviously related to this one, this 50% is X. Okay, so X will be 50, so A will be 50 minus 35, so A will be 15. Okay, so that is what is the actual meaning of A. A is related to percentage passing through 75 micron through this formula. Okay, but A is not exactly the percentage passing through 75 micron. A is related to percentage passing through 75 micron, and we have to subtract this percentage passing through 75 micron with 35, and whatever is remaining, that is A. Okay, then for B, what we need to do is, B is similar to A, but in case of B, B will be X minus 15. So X is similar to what we have got for A. Okay, X is similar to what we have got for A. Okay, percentage passing through 75 micron, and whatever we get here we'll write in X. Okay, percentage passing through 75 micron sieve. Okay, so we'll just put it here, and when we subtract it we get the value of B. Then what is C? C is whatever liquid limit we get for the soil minus 40. And what is D? Whatever plasticity index I get for the soil, plasticity index we get for the soil minus 10. So most of the confusion happens in case of A and B, and C and D are easy to remember. Okay, you just have to remember the fact that A is the percentage passing through 75 micron minus 35, B is percentage passing through 75 micron minus 15, and then C is liquid limit minus 40, and D is plasticity index minus 10. Then whatever values you get, you put in this formula. Okay, formula for zi, I have repeatedly written this formula. Okay, 0.2a plus 0.005 ac plus 0.01 bd, and then whatever value you get, then you whatever value you get, you can judge the soil from it, isn't it? If it is nearby 0, then yes, the soil is of a very good quality. If the soil is nearing 20, then the soil is of a very poor quality. Okay, so thank you very much.